Chapter 3 deals with the other trig functions. So in Chapter 2, we learned how to find the values of sine and cosine given any angle theta. And now Chapter 3 simply defines the other trig functions. Tangent theta is sine theta over cosine theta. Cotangent theta is 1 over tangent theta, which is cosine theta over sine theta. Secant theta is 1 over cosine theta, and cosecant theta is 1 over sine theta. All right, you should also recall that early on, the fact that cosine theta, sine theta at that point lies on the unit circle, we have what I said was the first Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. Well, now that we've got these new trig functions, we can take that identity and do a little algebra on it to come up with the following. So here it is, sine squared plus cosine squared is 1. Now, if we divide everything by sine squared, so take this, divide everything by sine squared, what do you get? Sine squared over sine squared plus cosine squared over sine squared equals 1 over sine squared. Now, I'm not saying sine squared theta because I'm getting too lazy, but a trig function needs the argument theta, so don't leave that out. All right, now if I simplify that, what do I get? Well, sine squared theta over sine squared theta is just 1. Cosine squared theta over sine squared theta, if you think about it with our new definition, is just cotangent squared theta, and 1 over sine squared theta is just cosecant squared theta. So let's make that change. It is cosecant squared theta. All right. Now, if I take this up here again, and I divide not by sine squared, but if I divide by cosine squared, I get this. I get sine squared over cosine squared plus cosine squared over cosine squared equals 1 over cosine squared. And with our new definitions, sine squared over cosine squared, that's tangent squared theta. Cosine squared theta over cosine squared theta is just 1, and 1 over cosine squared theta is just secant squared theta. So here are our new Pythagorean identities. We have 3 of them. One is this one. One is this one. And the last one is this one. Those are the 3 Pythagorean identities. All right, now what can we use with those? What can we do with those Pythagorean identities? And the answer is, well, we can use them to compute other trig values. All right, so let's look at, suppose I wanted to figure out the sine of minus 7 pi over 6. And of course, at the same time, I could figure out the cosine of minus 7 pi over 6. And once I have those two, I can compute the tangent, the secant, the cosecant, and the cotangent. Well, let's do that. All right, so I just have to figure out where on the unit circle I am at 7 pi over 6. Minus 7 pi over 6, right? So since it's negative, I travel in the clockwise direction. So I start in the positive arm of the x-axis. I go a 7 pi over 6. There is 6 pi over 6, right? That's minus pi. And then I have to go another, what? Pi over 6. So minus 7 pi over 6 puts me in quadrant, what? 2. By the way, quadrants are numbered, what? 1, 2, 3, for counterclockwise. All right. So here I am at minus 7 pi over 6. Well, this little reference angle right here is pi over 6. And so down here, I write that. There's pi over 6. I drop this perpendicular. This is my reference triangle. Pi over 6 is my reference angle. This angle is pi over 3. And lo and behold, that is a common triangle. And if it's a common triangle, I can fill in the values. Remember, I'm on the unit circle. Hypotenuse is 1. This side length is the square root of 3 over 2 then. The side opposite 60 degrees, or pi over 3. And this length is 1/2. All right, so the fact that I know this length and this length tells me that I know what this point is. It is minus root 3 over 2 and 1/2. The first value is cosine, so that's the cosine of minus 7 pi over 6. And the second value is the sine. And that's how I get sine of minus 7 pi over 6 is 1/2. Cosine of minus 7 pi over 6 is minus root 3 over 2. And once I have those two, I can compute everything else. What's the tangent? The tangent is the sine over the cosine. That's 1/2 divided by minus root 3 over 2. If I cancel things out, I'm going to get minus 1 over root 3. You can leave it like that. You need not rationalize it. What is the secant? The secant is 1 over the cosine, so that's 1 over minus root 3 over 2, which means I flip it, minus 2 over root 3. What is the cosecant of minus 7 pi over 6? The cosecant is 1 over the sine, but the sine was 1/2. So that's 1 over 1/2. I have to flip it. I get 2. What is the cotangent of minus 7 pi over 6? Well, that's 1 over the tangent of minus 7 pi over 6, but the tangent was minus 1 over the square root of 3, so I get 1 divided by minus 1 over the square root of 3, or minus the square root of 3. All right, so that's one example, and that addresses doing the parts of the homework in the first two tables. And in the next video, I'll talk about Roman numerals 2 and 3 of the homework. Hope all are doing well, and bye.